Okay, let's continue with another file. Well, another subject. In this occasion, we'll continue with directory content. Okay, a more powerful way to scan a directory tree is given to us the os.walk. Okay, let's check this method. Let's say it walking.py. Import os for root.dirs.files in os.walk. Okay, let's print os.path path, the method that we were working root if this let's print directories and for dir indios print dir dash underscore. Okay, very similar with files. File name, files, and file name. Okay, let's print a break line here. Okay, and now just let's execute it. This one must be named as walking. Okay, walking. Okay, let's run it. Well, you see here all of the files we got here. Okay, example B. I'm gonna create a new file, a new folder in order to just test it. Example in some.txt. Let's execute it again. I will see here file. Of course, you know this corresponding from example and some.txt. Okay. For the following subject, we've got file and directory compression. Okay. Before we leave this section, let me give you an example of how to create a compressed file. I have two examples. One creates a zip file, while the other one creates a tar.jc. Python allows you to create comprehensive files in several different ways and formats. Here I'm going to show you how to create a most common one, zip. Okay? And let's create a new. Let's take advantage of this folder. I'm gonna rename it. I'm gonna say compression. It will be named and zip.py. Okay, zip.py. With zip. First of all, let's import zip file, import zip file. Okay, so zip file example dot zip w as cp. Okay, cp create content1.txt, the same way content2, and you can say a subfolder content3 and content4. Another way with zip file example dot zip as cp dot extract content1.txt extract zip and subfolder slash content3.txt. Let's see what it does. Let's execute it. Of course, we don't have these files, so I wanna create them. Let me wait me. Okay, let's execute it again. Okay. Run. Well, I am executing this file from the current directory. Okay, not chapter 7. Instead, comprehension for directory inside. Okay, and let's execute it. Say zip.py, and you will see the example.zip was created, and also the example.zip was extracted. Okay, and you got here these folders and this file. Okay, and content3 and content1.txt. Okay, that's it. Now let's continue with another subject. In this case, the following one is IO streams and requests. Okay, IO stands for input and output. Okay, and it broadly refers to the communication between a computer and the desired world. There are several different types of IOs, and it's outside the scope of this chapter to explain all of them, but I still want to offer you a couple of examples. And so, using in-memory stream. Okay, the first will show you to IO string is that string IO.string IO class, which in-memory stream for the text IO. The second one instead will escape the locally of our computer and show how to perform an HTTP request. Let's see the first example. So let's omit this folder. I want to create a new file here, a string io.py. Okay, import io stream equal to io.string io stream.create learning Python programming. Okay, let's print become Python Ninja. So file equal to a stream. Stream. Okay, stream. And now contents equal to a stream dot get value print contents, and of course we need a close. Yeah, okay, let's execute it. In the Persisting code snippet, we import the IO module from the standard library. This is a very interesting module that features many tools related to the streams and IOs. One of them is string IO, which is an in-memory buffer in which we are going to write two sentences using two different methods, as we did with files in the first example of this chapter. We can both call string IO dot write, or we can use print and tell it to direct the data to our stream. I guess you know how to make this snippet more Pythonic, right? We've worked with open file and closing file, and this is very similar. So in this case we need with a string IO here as a stream. Okay, let's move here, and we don't need a stream close anymore. Okay, let's execute it again. I will see the same result. As you know, it's again a context manager. Like open IO.string IO works well with a context manager block. Notice the similarity with open. In this case too, we don't need to manually close the string. Let's see the following subject. Making HTTP requests. Let's now explore a couple of example HTTP requests. It will use the request library from this example, which you can install with pip. We are going to perform HTTP requests against the HTTP bin.org or ORG API, which interestingly was developed by Kenneth Reitz, the creator of the request library itself. This library is among the most widely adopted all over the world. This library is amongst the most widely adopted all over. This library is amongst the most widely adopted, but this library is among the most widely adopted all over the world. And let's create a new file called request. My request.py. I will import here request. Okay. Here I've got some URL Here are the URLs. And define here get content with title and URL. Request.get .get URL. Let's print response for title. Print dress.json. And also for title URL in urls.items and get content title.url print okay. Let's see security. Okay, what we've got here. Okay, let's see. It seems that it's something wrong with now. Okay, let me secure it in. Of course, we can reach now. Okay, well, don't worry, it's not working by now. I can remove it from here. Let me check again. Okay, agent and UID. It's okay. It was something wrong with now, but not important here. Okay, the most important here is that we are obtaining the response from these URLs using request.get. Okay, and printing as JSON in our console.